Well, people, again, good afternoon. We're talking about today about DYNJS, a project that I started a little bit of time ago. This project is really interesting. I hope you enjoy it too. Well, again, I am QMax. No one knows me by Douglas. I created DYNJS. I'm a JRuby committer. I really value and think that is important open source. It really changed my career and probably from several guys here too. So let's talk about DYNJS, which is our main thing. DYNJS, for you to understand how everything began, we need to look back a little bit on history. On this conference, this conference happened on March of 2011, and there was a problem, a basic problem, like on late year 2010. Some friend approached me, oh, I'm organizing a JavaScript conference, and I really want you to talk there. I was using JavaScript on my day-to-day, but I was, oh, okay, yeah, I can. And I started thinking, well, I want to talk about something cool, but at the same time, I'm just using what everyone is using. I'm just using JavaScript, and I'm not creating anything new or making anything different. So the crazy idea became, why not I try to make something with Java and JavaScript? So I started researching, and then I stepped at Rhino. Rhino, if any of you doesn't know, it's a Mozilla's implementation of JavaScript on the JVM. It's a really amazing fit, because when Rhino was created, we were talking about the JVM 1.2, and things was really, really slow, like by order of magnitude. And these guys did an amazing job, because they were even making some operations using bitwise statements to make things faster on the math side. It's really crazy. Like they really was ahead of their time. So the problem is that they was already of their time. Things evolved right now. We have much more tools to use and much more potential of making things easier and cleaner. The problem with Rhino essentially is that because Rhino had a lot of byte rot, essentially. We're talking about a code base of 12 years with more than 20 different contributors over time. So this is really, really, really old. And like, what would you use nowadays for generating bytecode? We have toolkits for it. They didn't have. So they did everything by themselves. So it's really, they really did an amazing job. But at the same time, I felt very frustrated. Like, I'm not a noob. I started reading the code, and I just couldn't understand anything. It was really complicated. I started debugging the code, like putting some JavaScript and trying to understand what was happening. So I gave up and thought, no, this is too complicated. If I really want someone to learn how to create a language on top of the JVM, I really need something different. And then my quest started. And I asked myself the question, why not creating a new runtime? I took the challenge. And before I start anything on the project, I decided how I wanted it to look. Essentially, I put 3 rules. The first one, I really wanted to have fun. It doesn't matter if the project will be successful or if it will be a failure. I just wanted to have fun and make something that I really enjoyed. So if the project became a burden, I will drop. That was my first thing in my head. And at the same time, I really wanted to learn something new. So I was already playing with JRuby a lot and bytecode generation, and I really thought that it will be a very compelling opportunity to learn something new and apply what I was using at JRuby and was making there. And of course, the Rhino code was so scary that I decided that I want to have something beautiful, because it was nearly impossible to understand that. And it's not their fault. The thing has 12 years. My code from the year 2000 is awful. Like, people evolve the codes. If the code doesn't get some treatment, it will be rot. That happens. So it's not their fault. It's the time. So I have an awesome idea. I had some very cool rules that I wanted to follow, but I have a problem. And that problem boils down that I really don't know shit about parsers. And so I wanted to implement a language, but I really didn't know how to make one of the most important parts of a language implementation, like converting the JavaScript code to something that I can use. So I asked for help, and then Porcelli joined the project. He's the hat guy. Don't ask him for take the hat. He will never do it. So, okay, we had a team, a guy that really expert on parsers, and like he gave me a working solution in like 2 weeks with AS3 grammar working, everything working marvelously. So I had the grammar, I had the parser working, so I needed to go to the next steps. And then I started everything again, the programming language design 101 class. First thing, I had a parser. I will start parsing this code, and then we'll go build an AST, and finally generate the damn bytecode. And I just stopped at this. As soon as I had a parser, okay, I'm screwed again. Because in reality, generating bytecode is easy if you want to generate garbage. To generate useful bytecode is really, really hard. So the next step that will be profit didn't happen at all. The reality is that I just kept fiddling with bytecode a lot of time. And then I go back to Rhino. I started to look, well, what these guys are using to generate bytecode. And what was my surprise? They were using long fields and making all the bytecode by hand. Literally. Encoding by hand. That's insane. Okay, they made lots of utility classes. And okay, things were working fine for them, but it was painful to understand. So for me, it was an option for bytecode generation. I couldn't use what Rhino was using. So then I will look at that to ASM, the ASM toolkit. And this version 4 supports now invokedynamic and all the stuff that I really needed. So it was a no-brainer. I just went. But at the same time, ASM was too low level. I even started using ASM, pure ASM, making all the things that I needed for my compiler. But it really, like in 3 days, it was impossible to do anything because it was so complicated that it just didn't work out. So I tried to find alternatives, and Charlie Nutter had made a very nice wrapper on top of ASM for generating bytecode via Ruby. And as I am jealous, because I liked Ruby, but I wanted to do it in Java, I did the Java port of the bytescript library. So you have all this potential for generating bytecode in a cleaner way, a way that you can understand better. This is an example of the JavaScript bytecode generation code. It's almost readable, almost. So there's several word conventions on the JVM on how you need to generate bytecode. Like a class needs to be like this car class is on the package lol. I have to use lol/car. There's conventions on the naming or what goes on the strings. So we have several helpers like the signature generation, the path, class path generation, and you just pass things and it generates the bytecode for you. It's way, way more palatable than pure ASM, especially because the normal way to use ASM is by using a visitor pattern. So you need to keep track of several things. The ASM has a better way to do it. There has some performance penalties, like 5% of performance penalty, but at the same time you can have a rich object model and put things on bytecode out of order, and it will fix it later. So JavaScript is using the ASM3 API, which is a little richer, at the cost of having a little performance penalty on the generation. Well, now I had a bytecode generation library, and it was working really, really fine. The next step for me was avoiding reflection, because when you generate a language, eventually you really need to generate like a method and call and all that stuff. In JavaScript, I don't have the luxury that I have on Ruby, on everything being an object. So functions are objects, and at the same time, they have quasi-like primitive type feeling. And I have the same thing I have in Java, boxed numbers and unboxing of primitives. And it was really not fun to make this work. As I wanted to avoid reflection, I will need to use the pointers that the method handles. But at the same time, all the work that I was doing on method handles drove me back to Haskell, because the roots are really functional. I really needed to grasp better operations like combinators, function folding, currying. So I learned tons of things on the process of making this work. And you can avoid it. We are living the revival of functional programming, because this method handles API is really new. Like Java 7 brought these new APIs. And these APIs are really functional. And the problem with functional code is that usually it expects that you have not a above the level brain. It expects that you are much more dedicated, because it's really hard. So in the end, this kind of API it has lots of power, but at the same time, it's not that easy to grasp. So the same code that I showed to you guys on the last talk about JRuby, using the method handles, the method type that defines the signatures of methods, and making a simple invocation. This code has some advantages, because as I said, when you use method handles, all the security checks just happen when you create the method handles and not when you do the invocation. So in general, things are faster. And yeah, it's fading. And of course, main advantage, they are immutable. So you can have much less problems with concurrency. Unfortunately, as I said, you really need to think more or like this to being able to exploit this API. Because the guy who created it is one of the most bright developers that I ever met at the internet. It's Remy Forax, one of the responsibles. This guy is crazy. I really can't follow him. Usually, I was asking like to Charlie Nutter, did you understand? No, not yet. I'm trying to digest it, like 3 days, trying to understand what the guy did. It just worked, but we didn't know why. So usually we have tons of problems understanding things that are too complicated. If it's too complicated, it deserves some abstraction, because it makes things easier for us to grok. So Charlie Nutter created invokedynamic, a GSL on top of method handles for making things a little bit more palatable. Or in other words, method handles for mortals. Really need to think forward and not backwards. So with invokedynamic, all the lookups that you were doing on the method handles, you use the binder and make the invocation from one signature. In this case, I'm just calling a a virtual method, but I could use something much more evolved, like converting signatures. Let's suppose I am able to pass a string for a method and make a condition asking if the string is true or false. There are some rules on JavaScript that you can use. I can do automatic conversion from objects to Boolean values, from primitives to Boolean values, and everything on the method handle chain. So essentially, the JVM decides when it will go inline or not, or when this will be optimized or already optimized. I just pass the responsibility of optimizing this stuff to the JVM. So for me, it's a big win. Way better. If you wanted to learn the method handle API, just go to invoke binder. Look at the tests. There's essentially a forward test, a forward creation with invoke binder, and the backwards test on the method handles for you to see the difference. So you can learn from the examples. Well, we have code generation with a nice DSL. We have method handle generation with another abstraction. That's really cool. The next step for a language implementation is to have a safety net. How do I know if I broke something on my last check-in? I really need to have tests. And we have the ECMAScript specs. It's like 1,700 tests just waiting to be broken. So it's a unique opportunity. And we just couldn't avoid it, so we created a project named DYNJS spec. So we were running during every any commit that we did, we run all the test suites. And this test suite is amazing. We have like 11,000 tests failing. That's a lot of potential to fix. Because every change you do, like on this case, I just made a little fix and was 13 tests less broken. So usually the progress is really fast, usually. The next steps for DYNJS, we are using right now the DynaLink framework from Attila Zezedji, a guy from Hungary, if I remember correctly. This DynaLink framework tries to simplify tons of things that you do with invokedynamic. The point is that it's too much magic. So right now, it has a model object protocol. The idea is that I can, with DynaLink, I can integrate different languages running on the JVM without serialization happening. So I can pass a DYNJS object to JRuby and vice versa, and things just happen calling between languages. It has lots of potential. But right now, the problem is that too much magic. So I'm not sure if this is a good idea for us, at least to continue supporting DynaLink. We need to evaluate this a little better. And finishing, I have a little demo for you. When we talk about DYNJS having a nicer code for you to read, I'm taking this very seriously. Like, how do I throw an exception? I'm using DYNJS. I'm using JavaScript. So I have a code block, some word object that just stores bytecode instructions. So in this case, I'm just getting whatever comes on the stack and then just throwing the object. So you can see that I'm using invokedynamic. Consequently, I'm using the bootstrap that I told to you guys on the last presentation. All that stuff that I was using, I'm still using here. And I have the bootstrap method here. This makes some comparisons, prepares a call site, makes, as I say to you, the invoke binder is really cleaner. So in this case, I have an object with this signature, really weird signature. I'm just putting where this call is happening, putting this new object that I just created on the same call, and just calling another method and telling the JVM, okay, from now, your target to invoke is this. And it just goes there. And things start like this, trying to make it most readable as possible. For the compiler, making a function invocation, function call, I just get all the arguments that I need to have on my function, put them on the stack, then just issue a call, dynamic again. So this code, it's not really documented, but at the same time, it's the most we can to avoid need of documenting it. So the name of the implementation, it's call statement, and inside the call statement, there's happening a call and parameter population. There's nothing more than this. That's the point. Bytecode is harder really for us to try to make some convoluted solutions. So another example that will be a little bit better, branch instructions like if. I just have the code that is coming that will evaluate to a condition that might or might not be Boolean. So I just do an invokedynamic call, converting whatever came into this stack to a Boolean, and then I can call again to get the primitive Boolean value for making a standard standard JVM branch instruction, like the if false, go to another label, and all that stuff that we see on the very, very basic assembly, that just go choose and if and go choose, stuff like this. So the code is like this. This is probably one of the most complicated statements that I have. So even if you never played with a compiler and really are curious on looking how it works and how you could do it, there's the code. It's open source. We love open source, of course. So it's on GitHub, and you for sure can play with it. So any questions? You got me exactly on what I'm working right now.
I actually work on a very similar project, and I've been doing that, so I know it's a pain in the ass.
Yeah, essentially, I'm making it here. It's not working yet because JavaScript has a very peculiar JIS behavior. The JIS is who calls the function. So if you are define a function here and call it, otherwise the JIS will be the enclosing function that is making the call. So I need to have this self thing on my stack. So essentially, I have a code that is inside the catch block. I just put it there and make all the things that I can do. And that's the whole point. As you can see, my bytecode generation is pretty minimal. What isn't implemented yet, and I'm just returning null. And this code will call again on my bootstrap method on a standard Java methods. The point is that I can implement things using the most Java I can, and at the same time having performance as if I was using raw bytecode. So I just take this guy. There's a catch, pun intended. Then I just get my exception that was thrown here. And I start making some conversions. I have tons of arguments here, but I really want to have an array of arguments so I can collect everything that is on the remainder of the method, like a varargs invocation, becomes one argument of a new call. So I will accumulate combiners to make a final call on the way I like. So essentially, the original call signature was receives a function, returns a function and receives an object. The final returns an object and receives tons of arguments. So I can effectively transform my call chain and put things and remove things, convert arguments, and everything is inlineable and optimizable by the JVM. So it's really a little bit simpler. As you can guess, right now it just says meh and don't work. But there's a start. Any more questions? Okay, thank you.